welcome everybody. Thanks for joining this webinar. Thanks to Geospatial World for hosting the webinar and helping us on this endeavor of promoting GNSS and what are we doing at the agency. So with no further ado, I will start the presentation. As you will see today, we will present and we will start with an introduction of what is the European GNSS Agency, which is a GSA, and what is our role towards the promotion and management of the GNSS programs. And then we will see more detail, a bit more information on Galileo and EGNOS, which are the two navigation programs from the European Union. And then at the end, hopefully we'll have some time for some questions. So as to introduce the agency, we are a European agency, which is managing the global navigation satellite systems of European Union. So the GNSS, that's what it stands for, European GNSS. And the main roles that we have is basically security-related issues for GNSS, for the GNSS programs. Also, exploitation of the services of the satellite services of GNSS, and as well market development of the program. We are an agency that its the headquarters are in Prague, but it's distributed in nature in different locations in Europe. So our mantra, one of the main goals of the agency is it's listening to the user and adapt the services to the user. So that's why our mantra is linking space to user needs. And of course, this is done over the two main services, which are Galileo and EGNOS. So one of the key activities, as I said, is market development. This is crucial for the development of the services and making sure that these services are tailored to the different user needs. The way we are structuring our work, it's divided in different market segments that are done exactly for understanding specific needs for each of the segments. This webinar today is going to be focused on the Geomatics market segment, which is that little guy with the theodolite that you can see in one of the icons. So for market development, we have three main pillars of work, which are market and user knowledge, understanding what are the user communities, the whole value chain, and what are the requirements and benefits that we can bring to these users. Then to support the demand, this is engaging stakeholders and industrial players to be able to adopt and help them support the implementation of GNSS. And finally, offer creation, in which we are intending to support industry, the creation of new companies, and strengthen the competitivity of the European industry mainly, but not only, since Galileo it's a global worldwide service. So our main work, it's most of it reflected in these two main documents, which are the market report and the user technology report. These are our Bibles, and they are released every 2 years. So they are bi-yearly publications, which are considered nowadays a reference on GNSS market status, and it's widely used and very widely recognized as a very useful document. So if you haven't done so, I encourage you to visit the GSA website and look for these documents, because it's a very interesting read on the status of the market for GNSS and the trends that for the next 10-15 years. Of course, these reports are free of charge, so you can download them anytime. Other of the documents that we are putting into the free into the public is the user needs and requirements for different market segments. This is a work that we are carrying out after talking to different users, user communities, and industrial stakeholders. This is an ongoing continuous monitoring process, but also we do this through our what we call the user consultation platform, which is a periodic event in which we engage all relevant stakeholders to provide insights on the requirements for usage of these services. So for the part of the offer creation, we have mainly we have a tool that it's research programs. We have two main research programs used that are the Horizon 2020 and Fundamental Elements. Horizon 2020 is a program that tries to foster the adoption of GNSS via the development of new applications and solutions that are using the GNSS programs, EGNOS and Galileo. While for the fundamental elements, what we are promoting or what we are funding is the development of hardware, meaning chipsets, receivers, and antennas that are supporting Galileo and EGNOS signals and differentiators. We have currently an open call, which is the 5th Horizon 2020 call, which is closing in 5th of March. So if you look for this call, you will find more information on what you have to do to apply and propose your ideas for innovation. Once this call will be finished, this is the last one from this program, the Horizon 2020, and we are now drafting the Horizon Europe program, that it will be the next research and development program from the European Union. Apart from these two main programs, we have also other initiatives that are trying to find ideas and innovative solutions for using GNSS, which is the development of applications via hackathons or competitions, application development competitions, or also we have annual prizes for specific market segments, which are the farming by satellites for the agriculture segment, or the collaboration we have with the CLG, which is the Young Surveyors Prize, which this might be more interesting for the community and for this particular webinar. We have been collaborating with CLG, with surveyors for many years. And as of this year, 2020, we will take over, the GSA will take over this prize. So we will try to promote this very soon. So please stay alert. So if you are interested, this year will not be only for students, but also for any young surveyor. So if you are interested in proposing your ideas, we will be very welcome to receive your submissions. So last but not least, the future of the agency is it looks very bright, thanks to the synergies of the different satellite programs from the European Union. We have a new EU space regulation, which will be in place in 2021. So thanks, as I said, to these synergies of Copernicus, which is the Earth observation program from the European Union, and the EGNSS, the agency will enlarge their responsibilities to manage also part of these new programs, which are Copernicus, GovSatCom, and Space Situational Awareness, mainly for the part of market development. So together with these new responsibilities, the name of the agency will change. So don't be surprised with if you see the new name starting next year, which will be the EU Agency for the Space Program, with the acronym of EUSPA. So as for introduction, that's it from my side. So I will leave the floor to my colleagues Anna and Eva, that will present you now a bit more details on the Galileo system and its specificities and usage for the geomatics market segment.
Thank you, Edward. We take the floor. So let's move now to see how Galileo can contribute to the geomatic domain. So the agenda to follow, to cover all the different topics for Galileo for geomatics, we will see a brief introduction and have a look to the Galileo system and the Galileo services. After that, I will leave the floor to my colleague Eva Ramirez that will continue with an explanation of Galileo for the use in the geomatic domain. So with no further delay, let's move to the introduction of Galileo. So we all know Galileo Galilei, the famous astronomer and scientific, and even that we could be here talking about him for hours, we are here today to talk about the other Galileo, the European satellite navigation system that, of course, owns its name to the famous astronomer. So Galileo is the civil European global navigation satellite system that provides global position and precise timing services. It is a joint initiative of the European Commission, the European GNSS Agency, and the European Space Agency. And as it is a new system, it has been designed to be compatible and interoperable with the existing American GPS system, the Russian GLONASS system, and the Chinese Beidou. So Galileo is a worldwide navigation system. It is made in Europe, and Galileo was born by and for the European citizens. So they could have a navigation system independent from the other already existing positioning system. It is also under civilian control. Galileo is fully interoperable with other GNSS constellations, meaning that one receiver can receive and process signals from different systems and therefore get better capabilities at user level. Galileo Open Service is free of charge and it is delivered in multiple frequencies, and this can help to improve the performance. And also, its modern signal design makes it more resistant to multipath. Galileo today is the only constellation that provides signal and data authentication, providing trustability for civilians. And in addition, Galileo will provide a free and global high accuracy service that will deliver position in the order of 20 centimeters. Let's see a brief history of Galileo. So on 1999, it was the first appearance of Galileo in the communication of the European Commission. And in 2003, ESA launched 2 experimental satellites to validate the concept. After that, in 2006, the first Galileo signal in space was transmitted towards the Earth. After the experimental phase, the first operational satellites were launched in October of 2011, and the first independent Galileo position phase was achieved in 2013. The year 2016 is very important for Galileo because the Galileo initial services were declared. With this declaration, it means that the European Union announces that the Galileo satellites and ground infrastructure are ready to use. The last 4 Galileo satellites have been launched in July 2018, reaching a total of 26 Galileo satellites in orbit. The completion of the constellation continues nowadays, with more satellites already bought and under preparation. So let's see how is the Galileo system, this Galileo system that provides the positioning and timing. Basically, the Galileo system is composed of 3 segments: the space segment, the ground segment, and the user segment. The space segment is the set of satellites that generate and transmit the Galileo navigation signals. Then we have the Galileo ground segment, which is composed of a range of sensory stations and control centers around the world, connected all of them by a secure network. And finally, we have the Galileo user segment, which is the set of receivers and devices that collect the navigation signals to develop multiple applications in multiple sectors. So to have a look to the Galileo space segment, we have today we have 26 satellites in orbit. Of these 26 satellites, 21 of them are in an operational status, which means that they are already delivering signals and they are contributing to the different Galileo services. Two of these satellites are placed in an eccentric orbit, and today they are being used for scientific purposes. And right now we have 3 of the satellites in a non-operational status. The Galileo ground segment is very complex, but this picture tries to show a scheme of how the Galileo ground segment is composed. The scheme is composed by sensory stations, control centers, and service facilities that all together compose the infrastructure of Galileo. But the important part here are the Galileo control centers, which are 2 centers located in Italy and in Germany. The control centers produce the navigation messages and transmit it to the satellites via the uplink stations. And also from the control centers, they are able to manage and control the satellite's constellation. The control centers are supported by a series of stations and service facilities all over the world that perform complementary functions. We are now in the Galileo user segment. So regarding the user segment, Galileo is used today on the majority of the personal devices and increasingly many consumer platforms. So there are already more than 1 billion devices using Galileo. If you are interested in buying a new smartphone or a new device, you can find a complete list of devices which are currently enabled to use Galileo in the website usegalileo.eu, which is managed by the GSA. And also a very important facility that connects the Galileo system with the Galileo users is the GNSS Service Center, which is the one-stop shop where the users can find all the official information related to Galileo. So basically from the GNSS Service Center, we manage and control a website where the official Galileo documentation is published, as well as technical and performance reports which are published periodically. Also, the users can see the updated status of the constellation, and they can receive notifications directly after registration in real time. The GSC also is born to provide access to Galileo system data. And today we publish the Galileo Almanac, but we are working on delivering more system data. And also a very important service that it is offered from the GNSS Service Center, it is the provision of a Galileo helpdesk, where the users can raise any type of questions related to Galileo, and a team of experts will try to provide an answer in a very short time. So we invite you to visit the GNSS Service Center, and feel free to visit the website and register, please. So let's move now to the Galileo services that are being delivered today by the system. So basically, Galileo is already offering a wide range of services. We have on the first place the Galileo Open Service, which is a free position and timing service, which is mainly used in mass market application. This service will be enhanced in the future with a data authentication feature. Then we have the Public Regulated Service, which is an encrypted service designed for greater robustness and higher availability. This service is delivered to governmental authorities. And the third service that is already in place is the Search and Rescue Service, which assists locating people in distress and confirms the help is on the way. These three services will be complemented with new services that will come in the future. The first one will be the Galileo High Accuracy Service, which is a free and global high accuracy positioning service that will deliver positioning in the 20 centimeter level of accuracy, and authentication services. The authentication services will be divided in 2 levels of authentications. The first one will be the data authentication, which is delivered on the Open Service signal, and it will be called the Open Service Navigation Message Authentication. And the next level will be the Signal Authentication service, which will be delivered on the E6 signal and will enable the encryption of the signal, of the codes. So now, if you are interested in knowing more and reading the official documentation of Galileo, you can access the GSC website, and there you will find the Open Service Definition document, the Signal in Space Interface document, which describes the signal, and also quarterly performance reports that are delivering information about how Galileo is performing right now. So now we will go to next point in agenda, which is will be done by my colleague Eva, and it's related to see how Galileo can contribute to the geomatic domains.
Okay, thanks, Anna. In the following slides, we will discuss some ideas about the role of GNSS in geomatics, and in particular of Galileo, the state of the art of this domain, the most promising trends in the market, and how Galileo new services will add an important value to the GNSS applications in the geomatic field. The current picture of the market is quite optimistic, as we can see in the figure of the slide. In fact, during the last decade, the use of GNSS devices in the geomatic sector has experienced an enormous increasement. As it can be observed in this graphic, cadastral surveying, mapping, construction centralize most of the shipments in the geomatic market. In particular, two are the main factors which have contributed to this fostering. The construction sector in emerging markets, which rely on positioning in a great extent, and the drop of the prices and new technology solution appears. Another important actor in the current situation or in the current market are drones, whose use for final geomatic solutions is becoming increasingly popular, and which motivated the development of many research and development activities. Dual frequency drones are now a reality and are common in the industry, and post-processing techniques such as the post-processing kinematics are capable of using GNSS functionalities to get accurate positioning during the trajectory of the drones. Finally, as all of you may know, there are several networks and associated services currently available, providing different services and corrections in several countries around the world. This will contribute to get better performance in terms of accuracy in areas where the coverage for certain networks is not good. The growth of these networks motivates the market for looking more attractive prices to catch new clients. Regarding the shipments of GNSS devices, the trend points to a long-term stabilization of the market, as is reflected in the first figure on the slide. During the last decade, it was Asia and Pacific area the ones who dominates the market, but now in the European countries, this shipment has also increased in the last year. Pressure on prices remains, what it a good signal. It means that some products will be spread in mass market. Some geomatic disciplines, such as mining, infrastructure monitoring, real-time kinematics networks, or marine surveying, are expected to live a moderate growth. The key actors who drive the market are those applications related to architecture, engineering, and constructions domain. In fact, GNSS is already present in more than 6% of the applications, from highways constructions, new smart cities design, and so on. The future is exciting, in fact, thanks to the integration with new markets such as Internet of Things, robotics, autonomous driving, and so on. In fact, related to autonomous driving, GNSS is one of the main contributors. High-precision GNSS is the source of reliable location data from all vehicle systems, ensuring critical functionalities related to positioning. Using GNSS, it is also possible to get optimal georeferencing of 3D points, cloud, and data acquired by other kind of devices such as scanner, cameras, and to create a real-time update of the high-definition maps that are embedded in the vehicle software. So the full integration of these elements with GNSS will mean a great progress in the development of a completely autonomous machine. The picture of the current market is more than promising, as we have just seen, thanks mostly to the fact that geomatics is an important cross-sector enabler. In fact, geomatics use many geodata collection services and tools for which high-precision GNSS is a must. Applications are focused on several fields, such as cadastral, construction of mine surveying, mapping, GIS, infrastructure monitoring, and so on. Other disciplines are also linked to geomatics applications, and usually these technologies are combined with GNSS measurements. In short, geomatics provides other business sector valuable precise data and versatile consultation services. But how does all this world evolve? How do we handle with new applications and how are new needs defined? Okay, Edward has discussed or commented at the beginning of this webinar the user consultancy platform. This is organized every 2 years by the GSA, and it is a forum for interaction between end users, associations, and relevant actors dealing with Galileo and EGNOS. In these meetings, new applications, new needs, or any issue that is considered relevant is discussed. The conclusions from this platform are used as an input to produce the user requirement report, which is intended to constitute a reference for the general surveying community by collecting and analyzing the most up-to-date GNSS user needs and requirements in the surveying market segment. On the other hand, this document also serves as a key input to the following consultation platform. So the main outcomes that are included in the report are validated, and in case it is needed, they are updated. You are invited to check this report if you are interested under the GSA web portal. And also, if you want to participate to define new requirements and do your bit, you can do it by filling the Galileo EGNOS User Satisfaction Survey, also available at the GSC web portal. So let us see what future brings. The trends in the market points to the technological revolution we are living. We can say we are living a fourth industrial revolution. And in particular, regarding to the Geomatic, we observe that even more or every day, they are more focused on implementation of solutions directly in the cloud, combined with other applications and solutions where some synergy is present. There's also software and added values offered by providers, by service providers, according to a prepaid scheme and offering corrections or processing techniques to the users. There is also new business models that have appeared in the last year, such as the capability as a service that combines GNSS with other geospatial techniques, offering an only one solution instead of independent solutions in different sectors. There are also many and different platforms to play with data, thanks to the flexibility in their acquisition. We can now access data from the mobiles, smartphones, tablets, navigators, and so on. And also the integration of building information modeling with high-precision GNSS observations provides great levels of automation and interoperability, and optimized decision-making for surveying and construction industry. But there is a lot of work to do because all of these emerging applications call for an update of the standards and the user requirements, and new applications arise. One of the most promising emerging markets is the use of the GNSS raw measurements that is now possible even from the smartphones, who are supported by an Android operating system 7 or above. In fact, there are already more than 1 billion phones that are capable of processing Galileo measurements nowadays. Also, the mass market already contemplates dual frequency receivers, whose cost is also reduced. To engage with leading experts in navigation and positioning, the GSA organized the GSA GNSS Raw Measurement Task Force, where the new needs, trends, or results are discussed in different workshops and white papers, with the latest testing results are guidelines. In short, mobile apps are becoming increasingly important in geomatics application, even more with the capability of the raw measurements usage. In particular, the use of these raw measurements in handheld devices leads to the use of advanced positioning techniques, and it opens the door to the use of augmentation techniques in smartphones, achieving accuracy below the meter. And now we will see which are the benefits of using Galileo. As Anna mentioned some slides before, Galileo offers a new perspective, in particular to geomatics, thanks to the service that this system provides, mainly high accuracy service, multi-frequency, and authentication features. Thanks to this service provision, the user counts with a greater availability and continuity, a higher accuracy, and also a shorter time to first fix. In the following slides, we will briefly see the main ideas of these new services. Firstly, regarding to multi-frequency, Galileo introduced this concept being E5 and E6, the second and the third frequency respectively. Obviously, multi-frequency improves results in harsh environments, such as urban canyons or tree canopies, since it allows an easier mitigation of multipath errors by the corresponding signal modulation a higher signal-noise ratio, and also thanks to the use of Galileo constellations together with other global positioning systems such as the known GPS. The use of multi-constellation improved for sure the geometry and enhanced also the availability, the continuity, and the reliability. And also the convergence time can be improved when integrated these multi-frequency scenarios with the PPP solutions. In March 2018, it was decided to implement this high accuracy service for the users. In particular, this is a free service that allowed innovation not only in consolidated markets, but also in emerging ones, and it will help in minimizing disruptions to the current business models or established providers. This service confers Galileo system a significant added value, since it will be the first constellation providing such accuracy service globally, and for free. Some details about this service are included in this slide. In particular, we can confirm that the high accuracy service will provide accurate satellite data and atmospheric data to allow the precise point positioning. These corrections will be transmitted through E6B signal using 448 bits per satellite and per second. And it's also planned the use of auxiliary channels to provide these corrections, to make possible that one receiver that is not capable of receiving this X6 signal can use the corrections also. The format of these corrections is based on existing standards that has been adapted to the Galileo frame. High accuracy service consider a multi-constellation scenario where at least GPS and Galileo are used, and the accuracy that is expected to reach is around 20 centimeters in the horizontal domain and 40 centimeters in vertical. This service will also contribute to improve the convergence for time regional services. And here are the three phases in which the Galileo high accuracy service will be rolled. The first phase, or phase 0, is the current phase, and it is where the capabilities are validated. Some tests are being done from the pre-recorded data, and this phase started mid-February last year and still goes on. During phase B, the performance target will be reevaluated on the existing infrastructure, and this phase is under procurement currently. And during phase 2, the full service provisions will be reached, and this phase is currently under design. And finally, the service of authentication, one of the most important features of Galileo. The authentication feature is categorized or can be divided in two levels. One of them is the Open Service Navigation Message Authentication, or OSNMA, and the Commercial Authentication Service. The Open Service Navigation Message Authentication is understood as a description capability for Galileo messages to guarantee the users that they are in fact using navigation data that do come from Galileo satellites and not from any other source that could be malicious. This service is transmitted through E1 frequency, and the description is based on a public-private key concept that is transmitted to the users in a secure way. The main benefit is clear. It helps to increase the robustness of the data against intentional or unintentional disruption. And the GNSS Service Center, the GSC, will host the core of this architecture. On the other hand, the Commercial Authentication Service is an additional encryption and authentication through the E6 signal. This service will contribute to increase the robustness for professional applications through the encrypting spreading code functionality, and it will protect the signal against more sophisticated attacks. Contrary to the OSNMA service, this one will be subjected to a fee by the users. In short, we can say that thanks to all these characteristics that we have discussed, the authentication feature is a Galileo differentiator factor with respect to other GNSS systems, being Galileo the only global navigation system providing such authentication feature nowadays. And just to finish, mention some examples of some projects where Galileo is already being used, and then they are evaluating the performances and the results. So the first one is Project GEMS. It's Geodetic Integrated Monitoring System, which is a low-cost system based on GNSS, Copernicus, SAR, and other in situ sensors to obtain ground deformation models that will be reached even the accuracy of millimeter levels. MapKite provides high accuracy and high resolution solution for the civil engineering to get geoinformation along corridors and the neighborhood, from the acquisition of both geospatial data from drones and land mobile mapping system. Galileo satellites are also processed to obtain this geospatial data that are analyzed within this project. And finally, the project Fantastic develops different technologies to allow for professional applications in 3 difficult scenarios and to evaluate the improvement of performance in such harsh environments. In particular, it is developed a combined technology of antennas technology and a multi-frequency receiver leveraging on Galileo specific features, mainly focused on the authentication capabilities and multi-frequency. And that's all on my side. So now it's turn to EGNOS for Geomatics. Thanks to all.
Okay, hello everybody. Thank you very much, all of you, for attending the webinar. First of all, let me please share with you Sophia's regrets and apologies for not being able, finally, due to a last-minute matter, to join us in this webinar. So I'm Carlos instead of her, and I'm trying to do my best to explain to you EGNOS capabilities and how they are applied for geomatics applications. So let's start with EGNOS basics. So I will explain to you very briefly the architecture and the services that are provided by EGNOS. EGNOS stands for the European Geostationary Navigation Overlay Service. It means first that EGNOS provides corrections for the GPS navigation signals, so it improves the typical GPS accuracy. Second, that these corrections are provided by satellite with all the advantages it has that we will see later. And third, that these corrections are provided for the European region. So EGNOS is the pioneer of the European GNSS services, as it's available since 2009. So it's working for 10 years, more than 10 years right now. It was initially designed for aviation purposes. It's important to have this in mind because it explains some of the features of EGNOS. But as the signal is provided by satellite and it's also available and it reaches the Earth's surface, it can be used for any kind of ground application, for instance, in the segments or domains of road, railway, maritime, agriculture, and of course, geomatics, which is the one we are explaining here. Another key word here is SBAS, which stands for Satellite-Based Augmentation System, because EGNOS is a specific implementation of SBAS service. It's the European implementation. As you can see in this map below, there are other SBAS implementations around the world. And the good point here is that all these implementations follow the same standard, the same protocol, so they are all interoperable. It means that with the very same equipment, you can go to any other part of the world where there is an SBAS system, implement it and use it and take advantage of these benefits of improving the accuracy. EGNOS is under constant evolution and development. So we are working right now in EGNOS version 3, which in the future, when it's ready, as you can see there by 2024, it will augment and correct. It means not only GPS signals, but also Galileo navigation signals. And it will do it not only for the typical L1, E1 frequencies, but also for the other second civilian frequency, L5 and E5. So it will provide more accuracy, more reliability, and more robustness to the GNSS corrections. Very brief, let me explain you how the EGNOS system works. So EGNOS relies mainly on a wide network of ground stations that are deployed mainly over Europe, although we have some of them in other parts of the world. These stations monitor constantly the GPS signals And as they are located in fixed locations, they know where they are. They check what the GPS signals tells about their position and can analyze the GPS errors. All this data that is collected by these ground stations are sent to what are called the mission control centers, which basically they are computation centers where all of this data is analyzed and processed in order to generate a correction model for GPS in the region of Europe. This correction information is forwarded to the space segment of EGNOS that comprises 2 geostationary satellites that are constantly operational, and even we have a third satellite as a backup that is ready anytime to run into action if needed, if there is any problem with the operational ones. There are 3 services of EGNOS. 2 of them are based on the satellite signal, the signal sent in space. Those are first the Safety of Life service. This is the service intended for aviation purposes. The reason is that it relies not only in improving the accuracy of the GPS signal, but also on getting the integrity data to assuring that the GPS measurements that they are getting are below a certain enough error. The problem here is that to use this service, you need a certified equipment, which is rather more sophisticated and more expensive than the typical mass market GNSS equipment. For this reason, for ground applications like this of agriculture, maritime, road, rails, and of course geomatics, where usually mass market GNSS receivers are employed, we use the open service, which doesn't rely on integrity information and only is interested in improving the accuracy. We have, so this service, open service, you have to use it like the typical GPS signals under your own responsibility. We have also a third service, which is called the EGNOS Data Access Service, so-called EDAS in short, which is not based in the satellite, in the signal in space, but it provides EGNOS and other GNSS data through the internet, as we will see later. So let's see more in detail the open service and EDAS. Regarding the EGNOS open service, you can see here the coverage area, the area where EGNOS corrections can be applied. You see that it covers mainly all European Union continental area and also a wide part of the ocean area, including, for of course, Iceland for complete, the Canary Island, Madeira, and so on. In terms of accuracy of the EGNOS open service, in order to get the real accuracy we can get with EGNOS, what we do is to take advantage of this network of ground stations, and in those stations we measure also the error we obtain applying the EGNOS corrections to GPS. So in order to get reliable figures, reliable results, what we do is to accumulate the data during a whole month and get some statistics. They are provided in the so-called monthly reports that are available in the EGNOS support website. We will see later. And in summary, the general accuracy in practice that is provided by EGNOS is less than an error than less than 1 meter in horizontal and less than 2 meters in vertical. It means in height. It's for the 95% of during the 95% of the time. In the case of EDAS, what EDAS provides is through the internet, as we already said, Not only the EGNOS message, the EGNOS corrections, and also the GNSS, any other GNSS data mainly from GPS and GLONASS that is collected by the EGNOS ground stations. But it also takes advantage of these ground stations that are located all over Europe to provide more local corrections in terms of differential GNSS and RTK. So these two kind of data in points 3 and 4 are the important ones for geomatics applications. So these corrections, as I already said, are only available in the surroundings of these ground stations. So if you want to check if your location is close enough of one of these stations, you have available in the website, in the EGNOS support website, this EDAS GNSS coverage map, where you can check any locations you want in Europe, and it will tell you if you are close enough to one of these stations in order to get RTK corrections that you can get an error less than 10 centimeters, or differential GNSS corrections where the error is similar to EGNOS less than 1 meter. Remember that these corrections are not the EGNOS ones, are special local ones provided through the internet, not the satellites. So let's move to the specific usefulness of EGNOS in the geomatics domain. Well, EGNOS is already wide use in geomatics application and activities. The reason is that EGNOS provides several important advantages for that domain. First of all, EGNOS is a free service, so it reduces cost. The signal is available in a continuous and stable way, so it's available almost 100% of the time, so you can rely on getting the corrections. Also, as EGNOS signal is provided by satellite, you get several advantages because of that. So you have really wide coverage. You don't have to depend on any ground infrastructure, and it provides the corrections in real time whenever you are. So due to these advantages, devices manufacturers, GNSS device manufacturers are smart enough to include EGNOS in their equipment, so it's available in almost all GNSS devices that are used for geomatics applications. As my colleagues of the GSC has already commented, the GNSS geomatics market is expected to grow in a continuous way for the next year. And as around the 90% of GNSS receivers include the option of EGNOS, EGNOS can play, and already play, but can play even a more important role in this market segment. You can find different types of devices that include EGNOS. Here there is a brief classification. You can find those antennas that are used with a pole, those handheld devices that includes its own screen and operating system. You can find GNSS-specific professional tablets. And if EGNOS is not available yet in smartphones and Android systems, we are working on it, as my colleagues of the GSC has already said with the raw GNSS measurements task force. But if you want to have EGNOS accuracy in your Android device, what you can do is to employ these Bluetooth-based devices. That is this kind of a small device that has no screen, that is only dedicated for GNSS measurements, but can be connected through Bluetooth to any portable Android device, smartphone, tablets, or notebooks, and have EGNOS corrections there. Okay, EGNOS is available in the devices, and you just need to activate it to use. But there is one thing you have to keep in mind and to be careful is to set correctly, to configure correctly the EGNOS satellites in the device. Some of these devices are smart enough to detect automatically the current EGNOS satellites that are operational in every time. But in others, you have to set manually the current EGNOS satellites that you want the device to use. So in those cases, you have to be alert and to check periodically the EGNOS website to subscribe to the EGNOS service notice to know which satellites are currently operational, because they need to be changed from time to time due to maintenance and end of life reasons. So please check the EGNOS GEO satellites and configure them properly in your device if you want to be able to use EGNOS. So yes, this was the theory. So let's move into the practice. Let's see in which geomatics applications and which use cases we have for EGNOS there. So basically, the applications and scenarios where EGNOS is useful comprise those cases where this submetric accuracy of EGNOS is enough for you. Cases where you have open sky, so you can see not only the GPS but also the EGNOS satellites, and when you need real-time measurements, and usually for several items. You have to check to get the locations of multiple items in short time. So the best option here is to use a handheld GNSS device with EGNOS. Some specific sectors of application that comply with these requirements are the management of natural areas, or the management of utility networks, or other situations where you have to do inventories or control of assets, for instance, of traffic signs or urban furniture. Other situations, other situations where it's useful EGNOS and people employs it is when people have to take measurements in the field, in case of law enforcement agents or biologists. And also it's very useful when you have to measure a perimeter. You can go with your handheld device and walk through the perimeter, and you get the measurements, the results with submetric accuracy thanks to EGNOS. Here, I will just say very quickly some success stories, so you have some proof that EGNOS is actually being used by companies and individual users. So here you can find examples. For more information, as the presentation will be available after the webinar, you can check the links provided here. But some example is for inventory of road milestones, or also management of forestry parks. Also, we have this case of the Slovak gas transmission system operator, EUStream. We use EGNOS here as a backup solution when the main high accuracy GNSS solution they have is not available. For instance, in those areas where where they don't have internet connections, so they cannot rely on the commercial solutions, they can use EGNOS as it's provided by satellite. Also for harbor mapping, for bathymetry and coastline mapping is used. And finally, also for in the biking sector, for leisure activities, the International Mountain Bike Association, specifically the European branch, is using EGNOS to locate the signal, the post signal that track the biking routes. And also several engineering companies, such as CGEOS Creative Solutions in Belgium, use EGNOS for this GNSS task, where submetric accuracy is more than enough. So just to end, let me share with you the point of reference regarding EGNOS in the internet is the EGNOS user support website. Here you have the address, but my advice is just to type in any search engine in your web browser EGNOS support, and the first link you find will be the one that directs you to the EGNOS user support website, where you find all the information about EGNOS. For instance, in the main page that is shown here in the slide, in the main page you can check very quick the current EGNOS satellites that are in operational mode, and are the ones that you have to configure in your equipment. So here the website is rather large, and there are a lot of information related mainly to aviation. So in order you don't get lost, here you have a compilation of the links that are more relevant for Geomatics applications. Here you have the links for the service notice, so you get the last updates about EGNOS system. Also real-time performance that you can check in all the locations of the EGNOS ground stations how they are performing in comparison with only GPS. Also historical performance if you want to check from previous days. There are a couple of guidelines very useful. If you have a device and want to configure EGNOS, the first thing you should do is to check these guidelines. First, there is a guideline that will help you configure the EGNOS in your equipment. And then you have a guideline to verify that EGNOS is actually being used and being applied in your equipment after configuration. There are very useful also these visibility maps. So you are to be sure that EGNOS satellites are not obstructed by any natural item like mountains or man-made ones like buildings in cities. And also very important and very useful, the EGNOS help desk is available 24/7, and you can send any question there about EGNOS, and it will be quickly answered to you. So the last thing I want to share with you is the EGNOS mobile application. So just let's be clear, this application don't allow you to have EGNOS accuracy in the GPS of your mobile phone. It's just a more friendly way to see the website in your mobile phone. It only provides the information of the website in a more friendly way, adapted to portable Android devices and iOS and Apple devices, smartphone, tablets, or notebooks. So that's all from my side. For any questions about EGNOS, you have here all the information, all the contact details of the help desk, as you can contact them through online form in the website, also through email or by telephone 24/7 anytime during the day. So thank you. This is all the information on EGNOS.
Thank you very much. We now move to the question and answers, and I request the team to answer the questions we have coming in.
Okay, I can take the floor for the questions. I have here some list of questions. I don't know if we'll be able to go through all, but let's try to answer them more or less in order that we receive them. So the first one is, which is the status of the PRS service implementation? Is it open to private users? So PRS is not open to the public or private users. It's mainly devoted and foreseen for governmental users. So like fire brigades, police, and other critical governmental users. As for the status, unfortunately, we cannot disclose, and it's out of the scope of this presentation. But in case you have specific questions on PRS, you can always contact our support team or on the GSA website, and it will be analyzed internally, and an answer will be provided to you. So next question. I find mobile apps very interesting. I would like to know about this. So I think here you're referring about the raw measurements. Here you can, of course, go to the raw measurements task force website. You can subscribe. You can be part of it. There will be, you will find there all the presentations that have been done in the different workshops. So you can get a lot of information from there. There is also a forum where you can share your thoughts, ask questions, and also find the support if you are developing your own application. So that's the main source of information if you want to develop your own application on Android and using this great feature. Next question says, I'm just wondering if there will also be a lesser accuracy for civilian use compared to military use for the high accuracy service. The high accuracy service is just expected to have two different service levels, but it's only depending on the region. And that is because of the number of ground stations. So there is not going to be any differentiations on the users. The service that is going to be provided by the GSA is going to be as such. Then, of course, if there are augmentation services that they are going to provide any added value over that, that's up to them. But the service itself offered by Galileo is going to be the same for everybody. Next question. Does the EGNOS cover Israel and Palestine area? Actually, because I studied this question in advance, so I had to make sure. And if you check the coverage map, actually Israel is just on the border, so it's in the 99% availability zone. So yes, you should get good coverage. Actually, there is a RIM station in Israel, as far as I know. So the answer would be yes. So next question, is there some statistics if EGNOS IDAS is really used by Geomatics users? The RTK feature is not very well known to the users, and maybe some promotion of this service will be beneficial. Indeed, for Geomatics users, we see that EGNOS applicability can be used for, and the accuracy that it's providing can be used for mapping applications and GIS. So yes, and this is what we are promoting, and part of the work that we are doing in this webinar. So it's one of our objectives that EGNOS is also used, and for some particular use cases, we find that it's a good alternative, free of use alternative. The next question: are the EGNOS correction messages for OS and SOL the same for the whole area of coverage? Same correction for Iceland and Israel? So maybe I will forward this question to Carlos.
Yes, of course not. The effect that the GPS signals suffer are different depending on the latitude and longitude. So we send different corrections depending on the location, but this is transparent to the user because we send the corrections for the whole Europe, and the receiver knows which corrections need to take and apply depending on the location it is.
Okay. Next question, which is a combined one. It's what is the difference in accuracy GPS device versus Android mobile, or is mobile replacing the GPS receiver? So if you are talking here about professional receivers, so for example, for GIS, so we see that currently it's not the case. The capabilities that are offered, or what you can do with a smartphone, even if you can get a higher accuracy, it's there is some limitations in terms of the antenna, the hardware that you can put in a mobile phone, but also the consumption of the battery of the smartphone. But who knows, in the future, of course, if you can use an external antenna, or actually, if you see the professional devices, they look like smartphones with some antenna attached. So it could go in that way. Can GNSS provide information to other continents like South America, and under which requirements? So for GNSS, we understand both programs, EGNOS and Galileo. EGNOS, we have seen the area of coverage. It is mainly over Europe and surroundings, but for Galileo, it's a global service. So of course, in South America, you will have the same level of coverage as in in the rest of the world. So yes, and there is no requirement. So basically, the requirement is that your receiver, being a smartphone or a professional receiver, supports the Galileo signals and is able to process them. Is there any difference between GPS cores? I understand it would be CORS networks compared to EGNOS services. No, the way of operating is the same. It's the stations are doing constant monitoring and applying the corrections. Just the type of applications that it's targeting are different. As Carlos explained, the EGNOS was initially foreseen for aviation, even if now we can see other applicability like in agriculture or even here in geomatics, as we said, for GIS and mapping.
Yes, let me complement that course network are more local. So it's similar to these EDAS applications we saw. Are more local, so you need to be in the surroundings of the network to get the corrections, and are provided also through the internet. And EGNOS is more regional, is more global for the whole Europe, and are provided by satellite. You don't need the internet connection.
Okay, and last question that entered the list is: please share about the application of EGNOS in Africa. I don't exactly understand this, but if you mean about the coverage, so again, you can visit the EGNOS support website and check the coverage. And you can, as Carlos said, there is this tool in which you can check the coverage in specific areas. So if you're interested in some specific area, there is coverage in the north of Africa. In the south of Africa, unfortunately, not. But check where are also the RIM stations and which is the coverage also for the EDAS service. So you can also be able to, you would also be able to use that. Okay, so those were all the questions. So I think we can close the webinar now. From my side and from the whole team, I want to say thank you everybody for participating.